All right, we're live.
Very cool.
Looks like we already have some attendees joining. Welcome, folks. I think we should probably give maybe like 3 minutes for folks to start filtering in. You guys have busy days today?
Very.
Always. Getting close to the weekend though. You're almost there.
Nice. Yeah, we just did our company-wide offsite for the year. And I got to meet a bunch of people I'd never met in person before, which was really cool. It was a fun time.
You went to Napa, right?
Yeah, we were up in Napa, yep, for a day and a half.
Go.
We did a Shark Tank style, new idea, new business competition. It was really cool.
Very cool. Who won?
There was one group. There was 5 groups, and one of them won. Obviously, trying to think. About the idea offline.
It's some really unique approaches to additional API integrations. That was their pitch.
Yep.
Very cool.
Sounds pretty sophisticated, entertaining.
It was a good time. All right, let's jump in. We have a good number of attendees already here, and they're continuing to trickle in. So we'll start out with a welcome and some quick intros. So first of all, thanks for joining today, everyone. So Axiom hosts a quarterly webinar on how data is being used to transform commercial refrigeration. And this is our Q1 2023 installation. So highlighting a few housekeeping items as we get started. As attendees, your camera will be turned off and everyone will be muted. If you have questions during the presentation, we ask that you enter those using the Q&A tab at the bottom of your Zoom screen. So there should be a button for that, and you can enter the questions there. And Joel is going to be moderating our Q&A session at the end. He'll be picking the most popular and most discussion-worthy questions to bring up in the last 10 minutes of today's discussion. And so we're looking forward to that part of the overall agenda. I think that's going to be a really exciting and informative part. We are recording this webinar today, and we'll make it available when it's ready to folks, just like we have all our previous webinars. If you hear something or see something you like from our panelists today that you'd like more information about, feel free to send us an email, and we can set up a one-on-one call to discuss more with any of the panelists for any of these topics. The last thing that I want to say here is that this is explicitly not a sales pitch for Axiom Cloud, for CBES, or for Effecterra. This webinar is really meant to start an industry conversation. Ideally, retailers and suppliers are going to be learning from our panelists' experiences with traditional alarm monitoring and cloud analytics, and helping to, number one, compare and contrast those things. They're not the same, obviously, but then also talk about how they can work together to provide a much better outcome than either one can by itself. And our goal is to help participants evaluate ways to improve their own maintenance strategies. And I guess lastly, there's no silver bullet solution that works for everyone. So we're going to talk about a lot of ideas and viewpoints today, but what we're talking about is kind of our approach to solving this problem and what we've learned from our experiences. And I'm sure that there are other folks out there who have different opinions based on their own experiences and their own learnings from working in the space for a long time. And that's very valid. So with that, let's do some quick intros. My name's Amrit. I'm the CEO and co-founder of Axiom Cloud. I've been helping grocery chains and commercial refrigerated facilities optimize refrigeration for about 10 years now. Refrigeration is a massive climate opportunity and a financial opportunity. The climate piece is why I'm here. It's a massive overlooked and underserved category. And we started Axiom Cloud a few years ago to solve the biggest problems plaguing the space using software and automation. And most of those problems center around refrigeration. So with that, I'll hand it off to Tom for a quick intro.
Yeah, my name's Tom Matthews. I'm Senior VP of Sustainability and Energy Services for City Building Engineering Services, otherwise known as CBES, which you see behind me. I've been in the industry for a few years, and This is a subject near and dear to my heart, so I'm looking forward to the conversation.
And Mark.
Hey guys, Mark Atherton with Effecterra. As you can see by my profile picture, I catfished Omrit from when I used to have hair. Looking forward to the conversation. Been in the industry for about 10 years, the majority of that time with Parker Sporlin on the controls and electronics side, specifically full site food retail controls for HVAC and refrigeration. Over at Effecterra now, doing technical program management, primarily on transcritical CO2 for food retail and HVAC.
Awesome. And Kyle.
Hey everyone, my name is Kyle Eastwood. I currently work for Axiom Cloud as the refrigeration specialist. I have going on 18 years of experience in the field and service work, and now I'm over at Axiom helping them get the refrigeration dialed in.
So really varied backgrounds here. Tom has been managing maintenance and energy optimization for grocery chains for a long time. Kyle's been in the field turning wrenches and managing service for a long time, and Mark's been working on controls and things for a long time. So really excited to be having this conversation with such a wide variety of backgrounds. So with that, let's talk about the agenda. So today we are going to cover, first and foremost, how are facilities using threshold alarms today? And then, what does that mean? And kind of what are the various use cases of threshold alarms? Secondly, we're going to talk about how facilities are using cloud analytics today, defining what that is and how it's used, and going through some examples as well. And then we're going to get into how alarms and cloud analytics work together to provide better outcomes than either one can by itself. And then we'll reserve the last 10 minutes for Q&A. So with that, let's jump right in. So what is a threshold alarm? So a threshold alarm is, it's triggered when a sensor value rises or falls below a predetermined threshold. So if temperature goes above a certain value for a certain amount of time, then alarm. That's the most basic form of threshold alarms. And so I think one of the most interesting pieces of this is that this is really the status quo. This is the only line of defense typically for commercial refrigeration systems today. When something's wrong, this is how we as stakeholders know that something is wrong, is because one of these alarms is triggered. And so I guess starting things off, Kyle, as a former technician, when you received one of these from a customer, what was your response to that? Did you know what was going on before you arrived on site? And kind of what did you do to begin the response to one of these alarms coming your way?
You would honestly just get told there's an alarm and they would try to read it off to you, but it's very confusing language coming out of the controllers. But it would be, I just have a high alarm going off and you dispatch accordingly.
Yep. And Mark, you've done a lot of alarms in your day, working on controls. I guess when you're thinking about how alarms are being applied, would you say that most folks are using just the temperature alarms, or are folks using the more advanced types of alarms as well?
I mean, every site's going to have the basic alarms, right? Like a basic threshold alarm, and it could be for temperature, pressure, safety line alarm, oil failure, that sort of deal. But most controllers have some sort of provision for some sort of advanced threshold alarm. Like on microthermo, other controllers, we've done cumulative alarms where you can do some fairly sophisticated things with that. You could also layer kind of standard discrete alarms on top of each other, but it's going to be one of those that not everybody's necessarily doing it. And I think we'll probably get into reasons why in a little bit. If I owned a store, I would absolutely have not only standard threshold alarms, but advanced alarms on top of that. But some technicians don't necessarily know exactly what they're looking at, and some retailers don't necessarily know the value of it.
Yeah, it's a perfect segue. So how are these threshold alarms being used in refrigeration today? Obviously, we've oversimplified this kind of dramatically here, and there's a lot of nuance that we're not catching here, but there's kind of the simple category of alarms, which is temperature. So, hey, the food's too warm. Pretty much as simple as that. And so that's arguably the most common. That's going to be found in nearly 100% of stores. Ideally, if a store doesn't have this, that's really, really bad. And so these are often going to be processed by store managers or on-site personnel or regional or local or national people. But generally, the people processing these types of alarms are not experts when it comes to refrigeration or technology. These are folks who, are begrudgingly dealing with refrigeration problems because they have to. It's not their main job in many cases. And so a lot of times they punt these along to various folks like the local service provider to really figure it out. Then there's also obviously the advanced alarms. And so this is a little bit less common, but this is what Mark was alluding to, where you start using these, the ladder logic and the kind of if-then type logic to layer on additional complexity and achieve more nuanced and, more advanced outcomes, essentially. So using identifying conditions that could lead to future maintenance issues or higher energy bills, identifying refrigerant leaks, and then flagging when folks are changing set points. And so, Tom, I think you have a lot of experience with more of these advanced type alarms from your experience at Baseline, where you were obviously combining the really smart folks at the call center with the software layer as well to provide better outcomes for hundreds of grocery stores at a time. So I'm wondering, can you talk a little bit about your experience applying these advanced alarms, kind of what went well, what didn't?
Well, the history of alarms within the business since these systems came into general use in the mid 80s, generally some of the more sophisticated alarm functionalities, when they get enabled, they quickly get disabled because they start spinning off more alarms than anybody wants to deal with. In the same way, the alarm targets for the reactive high temperature, high pressure, and other alarms get raised high enough that they avoid disasters, or at least give you a warning a disaster is coming, but they fail to capture all of the benefit you could have in terms of protecting product, protecting equipment, protecting compressors. If you were running them much tighter to the set points they probably belong in. We've gotten a lot of benefit from working closely with some of our clients, but we've also had to back off from more aggressive alarm set points when they started triggering too many alarms for the service providers. And this is because all these systems are just way too dumb. We're at the stage where we're better off than when the only information you had in an automobile was the red light came on, the check engine light, or something of that sort. We've advanced from that stage, but we're nowhere near the stage that modern automobile shows you or the tech or the OnStar what's going on with your system in some detail right now. So this intermediate point we're in, really because of the limitations of the controllers on their own, and I don't mean that they are excellent products, but they can't handle that much data, that much analytics. So the current position is a much lower value than it could be. And that's the frustration I've been seeing for 40 years, ever since these systems came into existence. Been waiting for when are they going to start delivering the full value that they can for their clients.
That's a perfect segue, Tom. So, why are more companies not using these advanced threshold alarms? And number one is there's too many alarms. So, this is a drum that I love to beat, but we do hear a lot of stakeholders telling us that they view refrigeration as a necessary evil. Folks telling me I'm here to sell groceries. I'm not here to fix refrigeration. That's the last thing I want to be spending my time and money and life energy on. And also, I don't know how it works. We hear that all the time in this space. I'm sure a lot of the stakeholders on the phone do as well, or on the call. So yeah, number one is too many alarms. So I'm sure a lot of folks have woken up in the morning and seen this panel kind of shown on the left here of a laundry list of hundreds, if not thousands, of alarms coming out of a portfolio of stores. And individual store managers, they don't want to see this. This is the last thing they want to see. And then you talk to maintenance managers as well, and they're buried. by emergencies. And so a lot of times, when we're talking to folks who work in maintenance, they're telling us we are already so far underwater. There's no way that we can become more proactive. We can't even put out the fires that we're dealing with today. So yeah, and then I guess on top of that, Tom, any comments on some of these other pieces here?
Amrit, the information there goes right to what Kyle was talking about before. The alarms are so dumb. The enunciations are so simplified that they're not useless. They certainly trigger activities, but they're well short of providing the value they could. The one that I think of, because it's not directed at the maintenance side so much as it is at store operations, is if we had a more sophisticated system that did temperature alarms on degree minutes, or looked at the full history, looked at what the product was in the case, we could tell store managers, not that their system was an alarm, but they need to pull the case or they don't need to pull the case, especially for the inexperienced personnel, at least in this area, who typically are in management positions in supermarkets. They don't want to know anything about anything except what they need to do to protect the product, to protect their customers, to protect their employees. And you can't, that's not in that list anywhere. That's just a list of stuff that they don't want to know. So, and we can't expect any of the control system providers to have enough power in those controllers, which are really quite inexpensive, to deliver higher level messaging and the analytics it takes to support it. It's just not going to happen. So, the cloud is the enabler that those people in the industry are like-minded to me. This is the enabler. We thought internet was going to take care of it, and all the information. We thought interoperability would happen and take care of it. We've all been waiting decades in some case, I'm sorry to say, for an enabler to come along. This has got to be the enabler. It's got to be.
So Kyle, when you were out in the field as a technician, did you pay attention to these types of advanced alarms, or did you view them as noise, or did you, did it really inform your operations as a tech?
Not really. It's more of an annoyance because, like Tom just said, it's a dumb alarm. They don't necessarily mean there's an issue. It could be a door was left open too long. So they're not really dialed in at all. So seeing all this, you get asked about, why do I have so many alarms by the customers? And you have to sit there and explain every single one. And yeah, a lot of them are just useless, or they mean something bigger, but doesn't know what that bigger thing is.
Amrit, 35% of the alarms that our remote services center handle, nighttime alarms, emergency critical alarms, are door opens and coolers and freezers. And how ridiculous is a decent algorithm running in the cloud could detect that right away just by looking at the history of how the temperature rose. It could communicate to the store on its own and leave the attention of the higher level staff who are trying to manage these systems to more critical problems, but that doesn't exist. So we spend a lot of money. These chains, all our clients spend a lot of money chasing these absolutely dumb alarms, which distract them from stuff that we really do need to turn our attention to.
So Kyle and Tom, I think you guys are really hitting on only experts understand the alarms. And then also there's just too many false positive and negatives. And I think a lot of that comes down to the fact that, if you take a set of rules and then you apply them across 500 stores, every single store in this industry is different. There aren't really standards that are universally applied. At least I have not seen that yet in my time in the space. And so I think those are two really big barriers that we're facing as an industry. Then the last piece here is that alarms are, by definition, it's an if then, it's a brittle kind of, it's a logic statement. And so if something changes, suddenly that logic statement is no longer valid. And again, kind of contributes to this Folks ignoring alarms, getting back to just too many alarms, too many false positive negatives. You change one of the end caps from frozen to fresh, and suddenly all the alarms go haywire. And before you know it, you're ignoring all those advanced alarms because
or it's 5 a.m. A store is using the freezer or cooler in the bakery department for a proofer or some pull product down, something they're habitually doing, they shouldn't be doing, but and you're triggering alarms all around that, and they just happen every day at that time, and the system is too dumb to interpret that properly and ignore the alarm.
Yeah, we'll put
I think another thing is that a lot of this, and Tom's absolutely right. There are situations where you could have a bad alarm, where the way the alarm was structured, it's going to naturally go off just by changes in weather or something like that, or like you'd mentioned. I mean, if you don't have a controller that's able to, have, I think almost all of them do, but basically if you were to have, like you just mentioned, an end cap, you got a dual temp end cap, you're switching from low temp to medium temp, obviously all of your alarm parameters have to change. So I think there's a lot of controllers that already have that. But I think a big thing, and you guys mentioned, is that just because the technician gaps and a lot of people are underwater, all of this is kind of, any of the advanced alarms are predicated off the end users being willing and understanding the value of taking preemptive action to have their stores run better. Because like Tom had said at the beginning of the call, you kind of have two different kinds. A basic threshold alarm is, we've got an emergency right now, you need to pull this case or you're going to lose product, versus we know the system isn't running optimally and it will eventually cause a problem. Now that could be 6 hours from now, 6 weeks from now, 6 months from now. But I think the big thing is that, being able to point at, we've identified what an issue is. We know that the system isn't running well. And here are the actions to everybody's point earlier. You need, what most of these controllers do not do is, you could set up a fairly sophisticated alarm, but it doesn't necessarily tell you what you need to do. Like, hey, I've got this cumulative alarm for X, Y, and Z. Great. Do you have the technician on site who actually knows what that means and what they need to do to fix the problem? And unless you've got something very specific, a lot of times it gets ignored.
Yeah, zooming out to what Mark just said, it's funny because a lot of these issues do kind of come back to the fact that there's just not enough qualified technicians in the space. And because of that, we're, squeezing the existing techs beyond belief. And so that means that the techs they don't have the ownership mentality. And, they don't have the time to really fix problems. A lot of times it's just about getting the food cold and getting out.
That defines the goals of everything that your company and others are working on, which is don't react to an alarm that's not genuine, a false alarm. Don't send a tech out if you can correct the problem remotely. If you do send a tech out, send them out with the information they need so that they already know what the problem is likely to be at the store that they're going to face, what they need to bring with them, and then they can be planning how they're going to attack it. I mean, the process needs to be eliminating burden on the tech workforce, which is now so scarce and so valuable, so that heavy dose of triage, and then a much better informed tech when they're dispatched to the job. That's what we need out of the web-enabled, cloud analytics-enabled progress that you guys and others are going to deliver.
Yeah. So I guess building on what Tom just said here, I think it's really important to state that the purpose of this slide is not to say that alarms are bad. Instead, it's to say there's a series of pitfalls which are making them less effective than they could be. And there are ways to help solve that. So, kind of setting up this next piece here, which is, what is cloud analytics? So getting into the next big chunk of our agenda. So what are cloud analytics? It is a tool that helps to solve problems before alarms, which is fundamentally different than a threshold alarm. And so it's kind of a three-step process. First, you have the enterprise visibility. So send the data to the cloud across many sites. And so suddenly that enables you to enable a technician to go in and remotely on their phone see what did one valve do every 15 seconds for the last 365 days. Or it enables the CFO to look across 500 stores and say which ones of these are the best maintenance performers or the worst refrigerant loss performers, things like that. So the highest and lowest levels of analytics and data visibility. The second piece is actionable insights. So once you have this enormous quantity of data coming out of the stores and the controllers and local weather forecasts and historical weather and utility grid signals and demand response signals, all these other inputs of data all getting fed into this database and collated and cleaned up and normalized properly. What do you do with all that? A human can't possibly manually interpret all that data. So that's where the data analytics and the AI comes into play. So that's where it can generate actionable insights with root cause, suggested actions, urgency, and value. So take all that and turn it into something that a human can understand and action appropriately. But you can't stop there in a lot of cases because, at least in retail grocery, we constantly find customers telling us, look, I don't want to buy a to-do list. That's the last thing I want. I already have too many things to do. And so the third part of a cloud analytics solution that can help here, that Axiom and other folks are doing, is basically applying automation to solve problems and address these opportunities behind the scenes without humans in the loop even. And that's optional. I know that scares a lot of folks in the space, but that's something we're already doing for some of our customers on a growing basis, is actually solving these things invisibly and then reporting on it after the fact. And we're going to give a whole bunch of examples of this in a few minutes here. But really high level, what I want to highlight here in the core thesis of today's discussion is that cloud analytics is not the same thing as alarms. And having alarms, if you have alarms, that doesn't mean that you've already solved the whole problem. There's still so much value in applying cloud analytics to solve all these pitfalls that we just talked through. So today, grocery chains and cold storage facilities are using cloud analytics to help reduce truck rolls, increase uptime, reduce the number of alarms, save on energy, and reduce refrigerant leak rates. We're going to give examples of each one of those in a second here. And then just really, really clearly, talking about some of these pitfalls that we were talking about on the previous slide. Cloud analytics is about reducing the total number of alarms. So we talked about alarm overload. This is a way to reduce alarms. This is a way to help store managers make better decisions, because ultimately you don't need that refrigeration expert to interpret something that's incredibly clear and simple and gives you all the context. So where is it? What is it? How do I fix it? How important is it? How urgent is it? How much money am I going to waste if I don't fix it? It also provides virtual sensors to fill key gaps. So in so many facilities today, you don't have the right sensors, or the sensors you do have, the quality of that data is kind of dubious in many cases. And so this helps to fill in some of those key gaps to cement understanding. And finally, it avoids a lot of these pitfalls with the brittle and damaged alarms that we talked about. So rather than dealing with a really simple if-then statement that breaks if anything changes, or doesn't necessarily apply scalably across hundreds of stores, this adapts and it learns. And it enables folks to make temporary changes, for example, and helps to ensure those changes aren't permanent to set points. And it helps to avoid these false positives and negatives by understanding the context of each individual store that's going to be unique, across a really wide variety of facility conditions. So I had a question here for Kyle, which is, how can cloud analytics go beyond these threshold alarms to improve maintenance outcomes? Maybe I've already kind of answered that, and I'm guessing you might just want me to go into some examples. Is that the best place to go, Kyle?
Yeah, it's the easiest to explain.
Okay, cool. Let's go into a couple examples. So, each one of these are examples from real customers, basically. So how can cloud analytics go beyond traditional threshold alarms to provide better outcomes for retail grocers and cold storage companies? Kyle, you want to talk about this one?
So this is the discharge pressure, and this is showing what happens when systems call for hot gas defrost. The green, orange, and black traces are showing that the certain times of the day, each type of calls for defrost in your discharge pressure tanks, the DDR valve was most likely going out on this issue.
Cool. And so this is different than a traditional threshold alarm, because we're able to really identify the urgency. This is not, doesn't need to be dealt with in the middle of the night, but you want to deal with it within the next 3 days. What happens if we don't address it? Basically, the store is at risk for a refrigeration interruption. When things get warmer outside, the store is going to get overwhelmed by that heat, right?
This is something that, oh, go ahead, Tom.
Amrit and Kyle, I think this slide also shows the progression or the transition. You said something in the prior slide that people might not be comfortable with cloud analytics, making decisions and correcting problems automatically. Well, cloud analytics, in this case, I think you have brought the analytics to the point where the messaging can be direct and the causation established. But even if you couldn't, the cloud analytics could serve this information up in this form to the remote services center engineer, technician, so they could do their job much more quickly. And you're going to have a whole spectrum of issues, from ones that are easily soluble automatically by the cloud analytics, even dispatched by the cloud analytics, and others which are too sophisticated yet for the algorithms, but the cloud analytics can serve them up in a ready-to-go form for the higher level analysis by the RSC technicians. And that'll keep migrating and migrating and migrating until the end. The RSC technicians, remote services center, whatever your triage group is, will only see the stuff that can't be seen. The best analogy I can think of is driverless cars. It turns out that maybe it's not a great idea for a car to be completely without a driver yet, but almost everything else can be taken care of automatically, getting you back in your lane, avoiding hitting the car in front of you. So we're going to go through that progression as well, but there'll probably always be somebody to make sure in the worst situation, the most complex and not discernible by the analytics situation, that operator at least will be able to quickly avoid crashing the store, crashing the refrigeration system.
Yeah, I got to agree with Tom here. I don't personally envision a future where humans won't be involved either. I think there's always going to be human involvement, but this particular anomaly is an example of, basically by getting this to the right person at the right time, at the right place, this one anomaly can offset, 50 alarms a month down the road. And so suddenly you've helped that call center that Tom's talking about, the response center, reduce the number of problems they have to deal with by 50-fold. And it's a lot less stressful too to deal with one alarm, at 3 p.m. rather than 50 alarms at 2 a.m. I also like Tom's quote here. It's a different ride to the store if you already know what you're going to find when you arrive. Well put, Tom.
Exactly. That goes along if a technician gets this report with the service call. When they're dispatched, they can know already, oh, well, first thing I'm going to go and check is see what my differentials across my DDR route.
And that's important for keeping people in the business. There's a tension associated for those service techs when they're dispatched at 10 at night, 2 in the morning. And if all they know is the store's in trouble, that's not that pleasant a ride. What the hell am I going to see when I get there is what they're thinking. Now they're going to know what they're going to see. They're probably going to know the store. They're going to be planning, what they're going to do when they get there, how they're going to get into that area. It's just, it makes the job more pleasant, less stressful, and more people will be willing to either get into the profession or stay into the profession. I think improving the quality of the technician's work life is completely doable. I would say that we're on the order of 20% of the nighttime calls of the ones that are left after we figure out the walk-in freezer door isn't closed. But of the remainder of the calls, many of those calls can be at least deferred to daytime hours by the actions of the call center people, or in this case, by the actions of the cloud analytics. They can take certain steps Older stepper motor valves often will lock up at the end of a defrost. That cloud analytics could cycle them full open, full close, same as our RSC operators do. And that means somebody doesn't have to go to the store until the next day. And that's critical to improving the quality of these people's lives. This has got to happen.
That example you just gave, Tom, is a perfect example also of, as folks like Axiom build more trust in the industry, getting authorization to do that automatically with software rather than having humans in the loop too.
It's a progression. Absolutely.
Yeah.
Yeah. And I know we've mentioned the technician shortage of both people and competency a couple of times, and by no means am I bashing on techs, because in reality, I think they're horribly undervalued for what they have to do. I mean, they're expected to be experts on all electrical problems, all refrigeration problems, know every version of every control system out there, every different rack manufacturer's little tweak that they put on their racks, every case manufacturer's thing. And then to your point, if they're doing, remodels, retrofits and things like that, it's typically always at night. And then a lot of times when these alarm goes off, if you're the guy who's on call and you're pulling the short straw, you're driving out to a supermarket at 2 o'clock in the morning, you don't necessarily particularly want to be there. So anything that you can do to make their job easier, I think will reduce technician burnout. And the more information you can give them, the better, because in reality, especially with some older legacy controllers, a lot of times they're not necessarily going to have the history to be able to dig through to find out when it was operating correctly the last time. That's one of the benefits about cloud, is you guys can pull data and bank it indefinitely, regardless of how old the controller is on site. If you've got a controller with limited memory, well, you guys are running a cloud platform. You don't have a memory constraint. So I think anything you can do to make a tech's life easier is going to be better for the industry.
Yeah. I mean, not only arming up the data, but hopefully eliminating those midnight calls entirely.
So, Amrit, I want to hop in before we go to make sure that we're answering some of the questions that are coming in.
Cool.
A lot of them seem to be around, sort of the current capabilities of the existing controllers, and then sort of what cloud can add on to that. So the first part of it is, what really can, say, like a 255 or an E2, can they do, time temp deviation calculations? Or are they limited to maybe these above low points? And then sort of following along with that, are these types of charts, this kind of information, available from the older controllers, or is this something purely that cloud analytics are able to deliver? And I guess this is kind of for everybody in the panel here.
I don't think you can be in this intermediate situation. The controllers would have to get so much smarter, have so much more capability, be able to store so much additional data that I don't think that's going to happen. In order to get to the point or get at the issues you're talking about. We've been waiting for it to happen for many years. I worked for one of the controller companies for a while, and we attempted to make all these advances, but we weren't able to with the capabilities that can reasonably expected to be in that controller at the price point that these controllers are provided. And I don't think you're going to get store operators to spend $100,000 for 2 rack controllers, or even 50 or even 10 instead of $2,000, $3,000, $4,000. So you've got to do the advanced stuff somewhere else. And one of the worst things you see in a controller is when custom programming gets done in it, instead of having a standard screen, which is what everybody, the techs, myself, anybody who works in the industry, you're used to canned applications and where the information is going to be. When somebody clever, a really skilled technician or engineer, gets in and does a custom program in the background with a loop sequence, control statements and things like that, that's a disaster for a tech going out in the middle of the night, but because he or she are not going to be able to quickly find those. That's when the analytics actually would be most valuable, because it would be able to steer them to exactly where the problem is, or exactly what control strategy needs to be corrected.
Yeah, I think it's a great point on the somebody writing a custom script, because you're absolutely right. there are techs that can do it. I mean, you could do it in Flex Combiner, EMPC, or whatever you've got, that you could write some sort of custom script to probably accomplish that. But then goes back to the point earlier, does anybody know what that's actually doing other than the guy who wrote it? And then what are the instructions on what it means? And then the other thing is, could you technically embed all of that stuff into a canned application? And to your point, the cost will most likely go up. But the other thing is that you could, the more variability, the more flexible that you make an off-the-shelf controller, it means the longer that it's going to take to program generally, because now you've got a million little checkboxes. Does it have this feature, that feature? Do you want to employ this, this, and this? And so you've made the controller more complicated because you've tried to build in more flexibility to it, and it takes longer to program now because there's infinitely more options. So when you can basically pull all of that out and just and slice it somewhere else, or look at it somewhere else, instead of forcing the rack manufacturer or the RC on site to program each individual little bitty set point. If you can do all that remotely, via the cloud, it's significantly easier.
And it isn't just for diagnostics, which we've mostly been talking about, because that's what Amrit is most intrigued by. I mean, the cloud analytics could bring a lot of value on the energy management side, where, you're looking at 4-day weather forecasts. You're looking at how the store performed, all the systems performed in the same situation in the past. And now cloud's reaching in, it's resetting condensing set points, it's resetting suction set points, it's moving the air conditioning set points around. Those are going to be incredibly valuable as we try and make the stores more sustainable by reducing refrigerant loss and increasing energy efficiency. So Amrit's surprisingly attached to the, and so are the rest of the team, to the improving the maintenance and service of these stores. And that's a dirty job they've taken on, and admirable. But there's that energy function opportunity out there as well that they may get onto sooner or later.
Yeah, let's in fact jump to that next here. I guess one final, first of all, great question, whoever asked that. What I would say is, it's not so much a question of capabilities, like Mark said, like, yeah, you could, pay a really smart software programmer to go and program this, but it's more about, like, why isn't anyone doing it? And the answer is all these pitfalls that we keep coming back to. So is it possible? Yes, but nobody's doing it for very, very good reasons. And this is a way to increase the functionality and the capabilities and the intelligence and the overall operations of these systems in a smart way that is going to make it accessible to the stakeholders who need it most, the technicians, the store managers, et cetera. You don't need to have a software developer sitting in each store, or that's obviously a exaggeration. But
I think another good thing to point out is that we're kind of coming at an inflection point in the industry with two different things. So one, we got the ability to do things in the cloud. It's hitting at the same time that case controllers are pretty much mainstream, and for a large extent, kind of the specification moving forward. And you get so much more data on valve positions, you've got more sensors. So the fact that you have the ability to slice things in the cloud is coming at the same time that you've got probably about 2 or 3 times as many data points in a store as you would have had 15 years ago. So I'm glad that we've got the ability both at the same time.
Yep. All right, Kyle, can we rocket through the next 3 of these? Because I want to touch on the energy one and on one of the refrigerant leak ones as well. Make sure we leave time for that. So can you talk about this one really quick and how it's different from a typical set point threshold alarm?
So yeah, this proves the threshold is not the best approach. This shows that the one case warming up out of a lineup, and on this case in particular, the high alarm set point was 25 degrees for an hour. So since it never reached the hour point above 25 degrees, it's just running warm with no alarm. So nobody knows anything's wrong with the case unless you physically go try to feel the product.
And so what's going to invariably happen, that as it gets worse over time, you can see it's getting worse over time. Eventually you're going to reach that alarm condition, and then it's going to be a big emergency, right, Kyle?
Yeah, exactly. So this is showing that those limit alarms aren't even doing anything in this case, and the case needs to be serviced.
Amrit, it's not unusual for a case to never reach that alarm and go like that for a period of years. And the and the department manager just works with it. They know how long the product can go in that case. They live with it. So these are the benefits for the operators that when we're pitching this stuff, we want to remind them of. Go ahead.
You don't need to be intimately familiar with every single corner of each display case in your store. You can have a new manager come in and be really effective from day one.
That's right.
All right, Kyle, what do we got here?
This flood back detected from a circuit coming in and out of defrost. We can see that from the suction line temp. This is something that the E2 usually isn't, or even MT. Not more in MT, they are set up to constantly monitor suction line pressure, suction line temperature for rack superheat, but in this case, it wasn't catching it. We could overlay what we needed to see what's causing it. And it was a case coming in and out of defrost.
Yeah, I think this is a really powerful example of, basically going not just step one, which is, hey, there's a problem, but going to step 2, step 3, step 4, which is, where's the problem? Oh, it's, case 40. And what is the problem? It's when it comes out of defrost, there's a pull down issue. And how do I solve it? You lengthen the pull down duration. So I really liked your quote here, Kyle. You're talking about, anomalies being like a cheat sheet.
Yeah, I have stood in front of an RDP for hours upon hours, tracing out wires, trying to figure out what's what. When if I could overlay more than just 2 sensors and kind of know a direction to go, it'd been a way easier.
Love it. So, would a store manager look at this and immediately understand what it's saying? Maybe not. But if folks like Axiom are building enough trust and there aren't, a lot of false positive, false negatives, hopefully a store manager is going to look at this, and we're seeing this a lot in our experience, working in the industry, and they'll say, hey, the urgency is medium. Looks like there's some decent dollars attached to this. I want to submit this to my maintenance company and get it addressed now rather than wait for this to become a big issue. And we're seeing that change of behavior already in many, many examples. All right, let's talk about energy really quick, and then we'll get into a refrigerant leak example, and then we'll get into more Q&A. So Kyle, you want to talk about this one?
Okay, so this is showing that if you have floating suction set up at over all your sites, how do you tell if you're really floating or not? How are you getting those savings from floating suction? The controllers aren't going to tell you if they're floating or not. If it's been disabled by a technician, if it's not floating because the lead case is just not operating correctly, it's not really going to tell you anything. So with this, we can monitor what's the float set point. Was it trying to float off of, and is the suction pressure really floating off of it? So it's kind of a view into everything, into the site on energy as far as floating suction, because you could save tons of money on just floating suction.
Yeah, and this is really the tip of the iceberg when it comes to energy. This is a very, very simple kind of the most obvious example, but it's also the most impactful, maybe. In 70% of grocery stores that Axiom goes into, float is not providing value, whether or not it's turned on. And this is across, at this point, I guess, 8 major grocery chains and 2 cold storage companies. And 70% of facilities, we're seeing stuff like this. And so we put out a blog post last year, 10 ways to beat the float. It's just amazing how many different reasons there are for why the float is not operating correctly. And so being able to identify why specifically it's not operating correctly, and then get folks out to solve that or solve it remotely using software, that can avoid a problem like this festering for years and spending tens of thousands of dollars per year or more in energy than you need to. I guess for this section group, it was $2,600 a year is what the software calculated.
It's not unusual to see many of the utilities in the part of the country we operate in pay a significant incentive to enable suction float in the stores, or in the store refrigeration systems. Tens of thousands of dollars per site are laid out in incentives, and you go back into the store a year later and sure, float set up, but the parameters is such that it never moves. It was false float, and the utilities would be interested in this program even more than the operators, perhaps. So to see what they're actually getting for their money, and everybody would save here if this was detected and corrected. This is way 90% of the time float has been disabled, and many of the chains we deal with. Some are much more diligent about it.
Yeah, I guess one of the really important piece here is that this is like whack-a-mole. It happens over and over again too. So, and that's one of the really important pieces of cloud analytics in general. Like, unfortunately, you can't apply cloud analytics once for one day, solve every problem at a site, and then walk away, because those problems are going to keep coming back week after week, year after year. And so even if we go and solve, maybe a technician came in the middle of the night and, spoofed a set point or whatever it might be to disable that float, and then, we fix it the next day. Maybe 3 months later, a different reason happens that the float gets disabled again. So this is it's a constant battle of making sure that we are helping the store to operate at a really high level.
And that's part of the making life better for the tech. The computer doesn't mind that it's having to correct the same problem over and over again. But a tech does. Any human being does. It gets frustrating. It feels like you're never going to make any progress. Better to let machines automatically make the corrections that we know are going to have to be made over and over again, and save the higher level stuff for human beings who need more stimulation and can be just beat down by the same daily grind.
Yep. Yeah, we'll put. Then Kyle, let's do this one and then pause on examples and go to Q&A.
Okay, so refrigerant leaks. So this is showcasing when the leaks started, which we're guessing is around December 27th, 28th-ish is when the leak started, and we can compare it to the ambient temperature. So we can see when the leak started, and then you can see it slowly going down after that, and this is when we'd send it in as a leak. We do check when we do this, all other leak detectors at the site. This site didn't happen to have any of the leak detectors just besides the receiver level. So we did compare this, and we you could see the slow dip of the actual percentage. So, but we can compare it to the ambient to see what it's supposed to be.
Yeah,
I want to emphasize to the audience that you're seeing a graph so they can present to you visually what the computer is figuring out. But the computer is announcing the leak, announcing the other and the other slides. They're not looking at screens. I mean, they may look at them afterwards to verify, but the computer is coming out with the announcement, hey, you're losing refrigerant in that store. And where additional data is available, it'll tell the operator, the service tech where. So don't get fooled by the graph. The computer, the cloud analytics are figuring this out. This is just helping us understand the behavior that they've seen.
that's really well put, Tom. Yeah, what we're seeing in the field is that there's some stores that have no level sensors in the receivers. There's some stores that have the digital switches, the level switches, and there are some that have the analog receiver level sensors. There are other stores that have only the sniffers, whether those are the back-rack multi-channels or they're the infrared. There's just a really, really wide variety of different sensing capabilities at these stores. And so, yeah, I guess we're really excited about what we've been seeing recently. In recent months, we've been detecting leaks at stores that don't have any data coming out of the receivers at all. This is an example of where they do have a analog receiver level, but we're detecting leaks very early at stores that don't have any of this type of data as well, and that's coming through that's virtual sensors. Would be happy to chat with anyone participating about how we're doing that offline. We're running low on time today though. So yeah, I guess thank you for that, Tom, Kyle. In the interest of time, I'm going to skip the next refrigerant leak example. We're going to go here and then we're going to get straight into Q&A. So getting back to the core thesis, why are we here today? It's to highlight that alarms are not the same thing as cloud analytics, and having alarms by itself is really not enough, especially when there's so much additional power that can come from the cloud to solve major problems that have been dogging this industry for decades. So yeah, I guess another maybe I'll pause there. Maybe we should go straight to Q&A. And I would be happy to go into any of these various checkboxes that are shown here as part of that Q&A.
Yeah, I think it's a really good place to pause there on it. The audience has been pumping in some really good questions, and I think what they're doing is really keeping us honest to the theme of this webinar, right? So it's, how do cloud analytics add on to sort of existing alarms and the situations out there? So, one of the big questions I think to start with is probably around the idea of sort of the logic that goes into some of this anomaly reporting. So we know that every now and then there's going to be anomalies. Sensors are going to misfire. We talk a little bit, for the panel about how, where do you draw that line? When can you ignore an alarm? When can you, use data, and maybe how can cloud computing help tell whether or not it's really something that needs to be addressed immediately?
These things can be handled on a rules basis. They can be handled with AI. They can be handled in many different ways. When we've worked on this on our own, one of the things we learned quickly was when a thunder shower came into an area on a hot day, you get a lot of anomalies out of the system as rainwater poured down in the condensers, and the condenser fans went off because the head pressures dropped. But that's precisely why you're doing cloud analytics, because it's got the power to find out when the data that you're collecting does not actually reflect a real problem. I take exception with Amrit on this particular slide because he's endorsing threshold alarms. I don't think even alarms should be done through the controllers. I think the controllers should control the equipment in the store, do that basic control, and provide an input and output port for the cloud analytics to do all the alarming. That's my opinion. But at any rate, the process is better known to people who do the work. So I'll shut up and let Amrit tell how this happens.
Yeah, Kyle, you want to jump in here?
So, yeah, I have a lot to say about it. So we're not trying to create more alarms. We're not trying to change what alarms do. Alarms are still needed, but cloud analytics is working differently, not to mitigate alarms so much, but more of an overall look at the site of why something's happening and predictions of what could happen from how the site's been running over time. And it's not there to replace the whole threshold alarms, and not saying I'm trying to come up with what Tom's pretty much saying.
Yeah, the thunderstorm example is really good. Where, with cloud analytics, that's the kind of thing where it can understand that context of the thunderstorm and then tell you, look, these 15 alarms are not valid or they're not relevant. And then also it can tell you, hey, here's 3 problems. And if you don't deal with them today or in the next week, you're going to have 200 alarms in the next 2 months. Exactly. Those are a couple of different ways to help begin to apply intelligence to reduce the total number of alarms that a human needs to manually triage or batch or respond to. So many of those are going to be false positives, and you're still going to be missing a lot of big opportunities and problems with those threshold alarms.
Yeah, I think just real quick on where do we draw the line for anomalies that can be ignored? I think ultimately that's kind of on a customer by customer basis, really, right? I mean, the individual end user supermarket is one who's going to tell you what can and can't be, ignored. I think obviously anything that's going to be like an immediate right now rack failure, or anything that is, product integrity, temperature related, is a thing. But then every customer has got a different thing of what can and can't be ignored. If it were me, I would be as proactive as possible. Obviously, make sure that you can do things they don't necessarily have to roll a truck today to do it, but put it on a list of things to be done. But yeah, the what can and can't be ignored is kind of end user based, I think, unfortunately.
I agree. Well, we're at the hour. So I want to pause the conversation there. It seems like there's so much more to talk about here, which is a great way to end a webinar. Thanks all for a really robust conversation, and thank you participants for your questions. Thank you for coming, everyone. And we will email out the recording of this to all registrants, and please reach out to any of us if you have any questions or are interested in learning more or talking through any problems that you might be facing in your situations that we might be able to help out with. So thanks all. Really appreciate the panelists. Round of applause for the panelists, and then also all our participants for being a part of today's discussion. Let's all push this industry forward together.